All right, everyone. So this is to show the third method here that we are going to declare the function and write a function in another file. How does that work? How can we do this? And later I'll show you how to do it here on online GDB using its C compiler as well. However, first I'm going to show you how it is actually done in a proper working environment. So here I'm using my Linux system, and I have created here three files: main, myfunctions.h, and myfunctions. And there's not any particular IDE, so this is I'm basically just using the Linux terminal, as you can see here. And here I have a makefile. I'm going to tell you what this makefile is later. And I have a main.c, myfunctions.c, and myfunctions here. So to start, I'm going to open NeoVim, which is the text editor that I am using for this. And disregard that. And let's see our files here. So I have my main. And in my main, it will be very, very simple, just as we had within our method 2 example right here. You see here, where's the main? Oh, the main is right here. So I basically just want to write this on my main file. So I'm going to include here stdio, and for now I'm just going to leave it like this. And I'm going to start writing my main function here. So I have my int main. I will not put anything inside my main for now. And I'm not doing it because for Arduinos later, that doesn't really matter. However, this method is the one that you actually use when working with microcontrollers. So it is very important that you learn the base first in using C. And then when we jump into Arduinos, you will see it is much easier over there. So in my function here, I have an integer x, which I initialized here, calling it 0. Then I have double my result. I'm also initializing it equal to 0. And finally, I start here by asking the user what is the number 81 the user wants to calculate the factorial. So type number to calculate the factorial, and I'll leave a space here for the user to put his input. So after this, I want to scan, right? So that will be our scanf function. And I want to scan an integer, so %d. And I want to save the result in the address of my input, which is the number x. And don't forget to close your semicolon. Finally, I will say that my result is equal to factorial x. And within this function here, factorial, it is going to calculate the factorial of the number x, and it's going to return the result into my result, as if I was doing my result is equal to 5. Instead of doing this, this equals to is related into a function. And it's telling me right now that factorial is not declared. So it's like the compiler at the moment is like, all right, Gabriel, what is it doing? Not the compiler exactly. This is called, so whenever you see this is called Language Server Protocol, or LSP. It is telling me, the LSP is telling me that I don't have a factorial declared. So it's throwing me an error, but we're going to fix that very soon. And then if my result is greater or equal than 0, then I am going to write here the result of the calculation. So printf not percent but \n, so it jumps a line to present it nicely and says factorial of the number that I have chosen. In this case is x, so I declare it here as an integer, as it is, and then 0.0f. F for floats or doubles. This 0.0, because of factorial that we're calculating factorial of positive integers, it's not good to return any decimal points, so just say that after the decimal points I don't want any number. So it is as simple as that. If it was 0.2, two numbers, so up to 2 decimal places of precision. So I don't need this right now. I use doubles because doubles can store numbers that are much larger than integers, and factorials, they are pretty large. So that's why we have it here. So I end it here. Let's put a dot just to look nice, and then I want to print my number x and my result. And that is basically it. If this fails, if this test fails, then I'm going to return 0. I mean, sorry, it doesn't return anything, and then we will return 0, which is the default here for our int main. Again, this return 0 is telling me that my main function has ended, and it's returning, let's say, 0 or something. It's telling the computer that this is the end of my program. It has been closed successfully. So right now it's telling me here that first in the LSP here in line 7, you can see here call undeclared function. This one we have already been there. Sorry, line 12. And 2 lines below that, I have here if my result, it's saying expected the parenthesis before after if. So let's correct that here. So I put it here instead of there. So now my LSP is just throwing in error, and I'm going to save it. So I'm going to write it. So it's just telling me that something is wrong. This function is not declared. Let's fix it now. So if I come here to my functions.h, you see here how in my file I have include stdio.h. So this is a header file that contains all the declarations of the functions that are included in the stdio library. That includes my printf and my scanf. So those two functions were previously declared in this stdio. So I'm going to do about the same as this stdio, but to calculate a factorial. So let's go to my functions.h. And in here, I'm going to include the stdio, because to calculate the factorial here, actually, let's see if I do need stdio. I believe I don't need stdio. All right, let's leave it like so. And so I'm just going to declare my function in here. So it is a double, so it's going to return a double. And the name of the function is factorial. It receives an integer called number. And that's it. That's everything I have in my functions. If the function within this function I knew I was going to need stdio or any other library like std libraries for the standard library, we're not going to use it at the moment. I don't think we need it. But I would include it in here as well in my header file. But I don't need it, so I'm going to save it. And now what I'm going to do is going to my functions.c. And in my functions.c, I am going to, you guessed right, include, but instead of this, I'm going to put it, because it's my own library, that's how we do it in C. I'm going to include my functions.h, and you see here that the LSP already identified I have the file within my folder, and that's all I need, I believe. So let's see here. I'm going to create my function again, so double factorial int number, as you see, it had been declared before. And I have to pause here because I'm receiving a call, of course. All right, sorry, folks. The call has ended. For you, it has been just a few seconds. So where was I? So we were here in our function where I declared the function here in my functions.h. So it is a double factorial, just like we had here. As you can see, it is exactly the same thing. And this is what goes into my header. And into my file, what goes into the file is my actual function. So the header takes the prototype, and the C file will have the function written as it should be. So let's go do this and finish the video soon. I also have to go through this make file so you know what happens behind the compilation of a C program. So let's go. Double my result is equal to 1, and if the number is, oops, there I was doing the same mistake again. So if number is equal to 0, remember that to compare numbers in C, we use the double equal, not just equal. Equal is just to say something is equal to the other. If you're asking, it's equal, equal. I believe that's the same for Python and any other language. But anywho, if the number is equal to 0, factorial of 0 is equal to 1. So I'm just going to return result, which is already equal to 1. You see that here I return 1, but result is equal to 1, so it doesn't really make a difference. However, if number is equal, oh my goodness, I always forget this. If the number is smaller than 0, then I am going to print my error message. So error. This function does not calculate factorial of negative numbers. And in case you're wondering, yes, we can have somewhat a factorial of a negative number. That a factorial is a result of a gamma function. So if you Google for a gamma function, you have it here. So this is the gamma function, very complicated maths, but the factorial comes from this. So if you Google for factorial of negative number, you see that probably it's going to fall into that gamma function. And yeah, you see the gamma function here. So it is possible to have, but this is too complicated for us right now, and that's not in the interest of this module to learn how to do that. So let's go back to basics. That was just a curiosity. And if the number, oh my, is greater than, 170, then I'm going to print an error. This function returns double and 170 factorial is the limit for that, and return -1. And finally, if none of those conditions are satisfied, then I'm going to calculate my factorial. And to do this, I'm going to use a for loop, and I'm going to create here an integer I is equal to 2, and then whilst I is less or equal than the number that I have typed, keep incrementing my integer I. So now I just need to calculate my result. result is equal to this. So what this is doing is basically what I'm doing here is saying that result is equal to I times I plus 1, something like that. So although I typed wrong there, but I said it. So this is it. And finally, I need to return my result. Call to, oh yes, so I indeed need my stdio because I'm printing stuff. So you see I didn't include into my functions. So let's go back to my functions. Oops. Let's go back to this time, do it correctly. So in here, I want to include stdio.h. Now let's save this here. Now if I go back there to my functions and save it, it shouldn't keep, oh, the name of the function I used is wrong. Of course, it's going to throw an error. So printf and printf. So you see that now the error is gone because I needed it here, and also I was declaring the name of the function wrongly, so it would throw an error anyway. But you see, I created my functions and I still have the issue because I haven't yet included my my header. So let's call it here. So include my functions.h, and ta-da, it works. So hopefully I haven't thrown this video into the bin. Let's look at our makefile. What is happening here? I am including my functions. My functions is here. It includes stdio. By the way, I think I can even comment this guy, and it shouldn't throw an error. Yeah, because the stdio is already included into my functions.h, and the function that is declared in here is written here, as you can see, and this is just the function that we had before. Finally, I come here to main, and we see that I include this, and I can use the function that is included there. I can include any other functions here that I want to declare, and then I write it here. It's not an issue. All right, it's not one file per function, as it is with the stdio. I have printf, I have scanf, I have puts, I have a lot of functions within the stdio library. So this is my own wee library. But how do I compile this, right? The way we're doing here on online GDB is we just run a file and we see it here. I can indeed create here another file, call it functions.h and functions.c, and I am able to, in this case here, I'm just going to copy my main function in here. It's throwing a lot of errors from the PowerPoint. To delete those, I have to hash include functions.h. You see that in here called my functions, here called functions, doesn't matter. And in my functions.h, I need to call this guy and delete those weird things. And in my function.c, oops, I can simply grab it here, copy and run it here. Delete those weird artifacts that PowerPoint throws. Oops. Oh, it was just a okay, done. So doing this on online GDB, as you can see, fairly simple. And if I run this now, I think it should work. So it is working, I guess. So factorial 5 is 120. Printf on function C, line 21. Include this, provide declaration of printf. Oh, of course, I forgot to include here the function .h file. Now everything should work without those weird, so factorial 5 is 120. It is working. Fine, but how does, what is the magic behind this? How does the compiler work in this way? All right, so let's see here in my makefile. So I'm going to open my makefile here on the left side. And you can see here that I can, this is a little bit more complicated. You just need to understand what is happening in the background. I'm not going to ask you to create a makefile, all right? If you use online GDB, that's perfectly fine. But here I create a variable called cflags. And within here, I'm just saying that I'm not using any implicit function declaration, but I am not doing that. Here I have all, and I will tell you what this all is. I'm going to start from the beginning, from the middle actually here. So you see that I'm from my functions.c. I am going to generate a file called my functions.c.o. This is my object function. So if we go back here to the lecture 1 and go to the part where I talk about C, you see here that you have this object code. This is exactly it. And then I have a linker that will get a library and will link with my object code to create the executable program. This is exactly what we're doing now. So I'm creating my object files. So this is the object for my functions.c. Here's the object that I'm creating, main.o, for my main.c. As you can see here, it will say compiling main. And then it is going to use the GCC compiler, which is a compiler for C, one of, there are many. So compilers for C. You see you have the GNU compiler collections, GCC, you have Turbo C, you have Tiny C, CLang, which is, by the way, which is giving me this very nice language server protocol aesthetics and formatting the file after save as well. LLVM, so there are many C compilers. GCC is the most common one. It already comes pre-installed in a few Linux distributions as well. If not, it's very easy to install. Anyway, so I'm using GCC to compile it here and generate the object file that I create here. And then finally, I will have my final. It is going to get my two object functions and it's going to link them into my final file. So thinking and producing the final application, I use the compiler with this flag. Don't worry about this again. And I'm going to link my functions.o and my main.o and create an output. This is -o here is the output that I'm generating. It's going to be called final. And if this all is going to just execute this final. How then, in this word, I compile my file? Why does it to be so complicated? Because that's life. So, oops, what am I doing here? I want to close all of this, as you can see, and I'm back to my thing. If I type now make all, it is going to call my O calls final, and final calls the rest. It's going to link, it's going to do automatically everything for me. And then you see here that compiling main, then it did the linking as well with the functions that I had, and then it finally created the final output. As you can see here, I have my main.o, my functions.o as well, so those are the object files, and I have my final code right here. This is the executable here in green. So in Linux, to execute something, I just put like this dot / the name of the file, and then type a number to calculate the factorial. 5 factorial of 5 is 120. Forget about this. This is just something from my terminal here. If I go back to main.c, and then here I go to introduce a line break and quit and make all again and run the code. So after 5, 120, you see that disappeared. So this is the magic behind a C compilation. We have all of this going in the background. For your case, we just need to worry about online GDB, because later on what we're going to do is to use this in Arduino. We don't need to run a makefile in Arduino. It does everything automatically for you inside the Arduino IDE. But you need to understand the basics and the fundamentals of it if you want to have a really solid base on when you go to program the microcontrollers. All right, this is it finally for this lecture and for this video, sorry. And I hope you have learned something from it. Right, bye-bye.